Have you ever wondered what happens to the seabed when bottom trawling is used to harvest kelp? Meet senior scientist Eli Rinde and her team at NIVA, the Norwegian Institute for Water Research, who are investigating exactly that.
When you trawl away the kelp, you remove the houses and the living spaces for the animals that used to live there. In addition to losing the kelp itself, as a high biomass of plant material, you also lose all of the associated biodiversity, both of plants but also of animals. At least in this newly trawled area, you have a kind of a desert compared to the untrawled area.
Norway has the second longest coastline in the world, providing space and ideal conditions for kelp to grow into thriving underwater forests. But in northern Norway, north of the Arctic Circle, an estimated 5,000 square kilometers of kelp forests have been reduced to barren seabed by grazing sea urchins. Blamed by historical overfishing, the lack of urchin predators have allowed their numbers to explode. The resulting underwater deserts have persisted for decades. According to Eli, much of Norway's coastline is open to trawling every fourth or fifth year. Forest areas are divided into trawl sectors, where commercial companies harvest up to 180,000 tons of kelp every year. And now, demand is increasing. Only small sections of these blue forests remain untouched as reference zones. This makes it challenging for researchers to pinpoint exactly where trawling has occurred and assess its true impact. Join Eli, Camilla, Maya and Janne, all scientists at NIVA, as they conduct field surveys to explore the impacts of kelp trawling and why this particular area was selected for the research. We are off to the island of Smøla, on Norway's northwest coast, surrounded by thousands of small islands and jagged rocks rising through the water's surface. Clinging to these rocks are some of Norway's most pristine kelp forests, resilient and swaying in the ever-flowing currents.
The same survey was done in the 90s by NIVA's researchers, so we have data that can be used to compare the present state to the state observed about 35 years ago. So now we can compare both the recovery rate of the kelp as well as of the associated biodiversity. So we can see if there's a need to maybe prolong the time before next trawling, but also how the ecosystem itself has changed over time due to maybe also climate change.
Operating from a sturdy boat equipped with drop-down cameras, diving gear and decades of expertise, the team surveys areas that have been recently trawled as well as those trawled 1 and 4 years ago. They also visit reference areas that have been protected from kelp trawling for several decades. After 35 years, a new generation of marine scientists has returned to deepen our understanding on the impacts of human activity on the seabed, which remains out of sight for most of us. But what motivated the studies more than 3 decades ago, and what did they uncover?
The motivation for the survey in the 90s was to evaluate the ecological consequences of kelp trawling and to assess the recovery rate of the kelp plants itself and of the associated biodiversity. So the kelp plants provide living spaces for numerous of species, both on the holdfast and on that anchor the plants to the seafloor, and on the long stipes. We found that the kelp plants quite rapidly recolonized the trawl tracks, and that full size was achieved within about 1.5 years after trawling. However, the associated biodiversity took longer time to reach the level found in the untrawled kelp forests. So the mature community that you find in the pristine forest had not recovered 6 years after trawling. The level of biodiversity was lower, so the community had not recovered as much as it should have done to be similar to the community that you find in untrawled kelp forests. So it means that you have to have a longer time period than 6 years to get the biodiversity back after trawling.
Back then, Eli and her colleagues Hartvig Christie and Stein Fredriksen observed a decline not only in number of species, but also in the number of individual organisms returning to their habitats or kelp plants as they regenerated. So, what have they discovered over the past 35 years? And how often has this type of survey been repeated since?
A similar detailed study of the recolonization of associated flora and fauna has not been done since the 90s. The reasons for repeating the study was observations in a research project called Massimal, where we used drone imaging to develop methods for mapping the distribution of blue forests, such as kelp. But sadly, we saw that the kelp trawl tracks were overgrown by filamentous algae, and also that it occurred a lot of an opportunistic kelp species, more of the opportunistic kelp species than of the common and long-lived tangle kelp. So we were concerned that the recovery ability of the tangle kelp had decreased, and also that the ecological state of the kelp trawl tracks was poor.
Areas needing attention underwater were located from above, using drones equipped with hyperspectral cameras. The results have guided the work back to the island of Smøla. Although this extensive survey is far from complete, Eli Rinde shares some insights of what they have uncovered so far.
We have not analyzed the data from the field survey yet, so we cannot provide any certain answers. However, the observations indicate that the kelp plants are smaller than 35 years ago, and that the time for the kelp plants to recover is longer. And when we have analyzed the sample data and compared these to the previous study, we will know more about how much shorter and how much longer the recovery time is, and also if the associated biodiversity has decreased now compared to before.
After another long day at sea, the team gets stuck into cataloging the plants brought back to shore, and I ask Eli if she's concerned about what seems to be a growing demand for kelp.
If the results is like they seem to be, that the recovery rate now has decreased, I think maybe we should, or at least we should consider the harvesting strategy, think over again. I don't think it is wise to have all the area open for kelp trawling. I think it is important that you set aside wider areas that are not trawled. So, like in a forest on land, that you know exactly which area is a kind of industrial forest and which areas are natural forests.
Throughout their careers, Eli, Maja, Camilla and Janne have spent countless hours submerged in the blue forests, monitoring, surveying and keeping a watchful scientific eye on this vital, life-sustaining ecosystem. Surely diving and swimming in pristine, ancient kelp forests, designated as reference areas, would give a senior scientist reason for optimism.
Kelp plant was not as old as they were before. They were very tall and it was very beautiful. I think it was more homogeneous now than we observed 35 years ago, but this has not been quantified yet. So we are a little bit concerned if maybe this area can have been trawled. We don't know. Because it was in an untrawled kelp forest, it is very common to have a mix of old kelp plants and of small kelp plants. And we saw that also, but maybe not as much as we hoped to see. I feel very, very relaxed and overwhelmed by the beauty of both the kelp forest and also the merle beds and the seagrass beds when you experience them in a healthy condition. Yeah. So it's very sad when you see signs that they are not performing as well as they should.
What are Eli Rinde's hope for Norway's blue forests?
I hope that we can provide enough guidance to stop pollution and to stop to build down nature and to use the knowledge that we have so that we can repair the habitats that need to be repaired.
A silent seabed remains where a vibrant forest should be. Documenting the work of NIVA's scientists unveils the fragile beauty of these underwater worlds. Ascending back to the surface, I wonder what the future holds for these hidden Arctic jungles. Will pristine, untouched forests still exist on land and beneath the ocean for generations to come?